Hello, I'm Chris Athenis. I'm a KMP developer. That light needs to be turned on. Tech Sports said they're coming out on that. We get that as soon as possible. Today, I'm going to be going over an app I wrote a while ago. I never did, and I was making videos, and it's called Tasky. And it's a time management Google Calendar, like Google Calendar, and I did it to explore, compose, and Ktor, and front end and back end. And this is kind of what it looks like. The UI looks like, and hey, this is not the review of the app, the front end. I'm gonna be going to the back end. I just want to give you an idea what I have. What the back end is this for? It's for this task management app. Here's some of the screens here. That's the different tasks here. This is a login screen right here. It has notifications. It's not a KMP app. It was before I was doing KMP, but it's composed. I mean, it's like 98% of it is composed, code teams, everything. So it's all Kotlin. It's written in Kotlin. And here's the link to the back end server. And here's how I built it and some more notes. And here's the flow of the screen, so you can get an idea of how the front end was designed. And had the presentation here without the different layers and the architecture diagram, how the thing's set up. There's a DAO to an API. So we got a database here. We got an API that goes to the network, and the network is the Tasky backend, which we'll be getting into in a second. And here's all the entities, how they're kind of related in the database. And yeah, so that's kind of the architecture. You can go here, all the different endpoints that are available, and what the responses are going to be, and version history. So that's that. And to do the Tasky backend, you're going to have to go and make an account on iDrive EE, which is okay. This is the Tasky backend, and now I'm going to show you what I was talking about. So right here, here's the README. Yeah, so this is the Tasky backend. It's all Kotlin. It's written in Ktor 3 using Coin 4, which I had to do some odd things to get that to work here, just so I'm mentioning it right here. To inject, through the injections, it wasn't working on the route, so I dugged it, and it's really cool with Kotlin because you just add an extension. I don't have to change the whole library. I can just add one thing, and the functionality starts to, I get my functionality without having to go dive into it. Let's see. I don't know why it's doing that, but let's do this back here. Okay. So let me make this smaller here. All right. And here's the link to the Tasky GitHub, Tasky app, Android app. And here's the Kotlin 2, Ktor 3, Coin 4, and you have to go in to. I'm using iDrive. You can use AWS if you have an S3. If you have an AWS account. I've got code here that sets it up for the S3 account, but I'm using the free iDrive E2 bucket and free Mongo Atlas. So you have to go get the credentials from there, and then you want to right here in this example shows you where to set up all how the screen strings are supposed to look, the access codes, the passwords, everything you need to do to set it up. You need to user define these ones. This is for generating API keys on the server. So that's for it. And here's for local development. If you want to run a local instance on your machine, on your development machine for Mongo, that's how you do that for a local string. It's a little bit different, and you have to yeah. So that's how that works. Okay, here. So the databases you have to set up are these 6 databases, which after you go get your MongoDB set up, you get to set these what is it, 1, 2, 3, 4, 7 databases. So user. And you just have to create the database and then just create a table with just nothing. They're empty. The API keys that you generate for each one of your users. Here's the attendee. This is a database that's generated from when we create events. Here's the event database. Here's the kill tokens for the authentication tokens when they get expired. And here's the reminder database, the task database. So it's basically an app to do time management. So you can set up events, you can set up reminders, you can set up different tasks, and it'll show up a notification and do an alarm on your phone. That's basically the idea, and it explores using all these different APIs and also being a credentialed, your keys are all in different credential files using Hocon. So Hocon files. And that's the example right there. This is the actual file here, so I'm not going to show you. Here's another Hocon file for configuring the application server. And here's the app module for Coin. Using Coin to do the injection. We're creating the Mongo client and the Mongo database link, the connection to the database. Here's all different aspects of the. If this is so much nicer than Dagger, in my opinion, I might use a little performance at runtime for when it has to access this stuff. But man, it's just a lot nicer. And the error messages aren't bad. They're not great, but it's the dependency injection. What do you expect? You could probably get away with doing this manually without having to use all this dependency injection, but I wanted to understand it, so I went through and figured it out. So it's creating all the different objects in the application that are then used over here. So that's your configured coin right here. This is what that does. And this is gets all your environment variables from one thing. It's usually either going to get them from the environment variables from the process that launched it, or from a configuration file, which is what I was showing here. This configuration file here, and it goes through. And this is the application or the function that goes through and gets those things, assigns those secrets, and makes it part of the environment. That then is being, so we can do that here with the environment variables there. This is where you get the token configuration, which is using all these different variables here. And then we configure the security, which I'm going to go into detail right now. I'm going to get a drink of water first. Okay, so here's how the security. I'm actually using 3 different types of security configuration. One is called basic, which is just for when creating API keys for different clients. Each client has to have each person that creates a client. Each one of the clients has to have this API key as part of it. So that's with I save the API key with an email for all the people, all the clients that may be using, may be creating clients like Tasky application, which there's only one in this case, but it's set up to have, if there's multiple developers doing multiple clients that want to access the database, you can create an API key for each one of the clients. So if somebody starts screwing up or gets deprecated, whatever, you can get rid of the API key and they lose access. That's what that's for, and that's called that. And we're using basic authentication here, which is username and password to access here, which is right here. This create API user, create API password, and it validates it using a database. That uses this one right here. So it goes and validates that this API key, it's this person right here created it. They get the API key and it just checks to make sure that's actually a valid credential. And this is for protecting these different routes. So like the authenticate route has an API key. You have to have the API key to log in or register. And some of them to authenticate, you have to have a JWT. That's for actually when after you're logged in. So after you log in, you get a JWT token, which is your authentication token that you can then use, that is then looked at as opposed to your API key. When you log in with the credentials, you're going to get a JWT that then has the authentication token in there, so that you can be authenticated here or any of these routes. They're going to check that token, which comes in through the header. They're going to check it on every time the backend is called by the client, the front end client. Here's a log out. You have to use a valid JWT to log out, which then deletes that. So here's the how you create an API key. We're using the basic authentication, which is username and password, has to be attached to the header, and then it's going to check to see if the API key is good to then create an API key here. So well, actually, no, you don't actually need the API key. All you're using is this username and password, which is right here, which is like a special username and a special password that's just for the guy that's running the server, which is me or you, whatever case they be, and to allow that particular client to, that's going to be calling and making those accesses. That's what authenticated. So this is what this is for, as opposed to letting anybody call in or having one key, and then everyone uses the same key. It was one key assigned to each user, each email, and you can individually get rid of people if it becomes a problem. That's the whole. That's it's a security. It's another layer of security if you want to go. And I've shown you how to do that here. And then we're gonna generate an API key. It checks to see if it's one in there. If it's one in there, it'll refresh it. It'll create a new key. And if there's right here, source API create key, and that's right here, and that goes into the API data source, which is going to be either the fake one for testing or the Mongo one. So I'll show you the actual one, and let's just look at this. And so it says is it a valid key? It goes and checks the database, and if it's between now and expiration date you valid from versus now. So this is what the data looks like over here. So it expires at, valid from, and notice it's using these UTC strings. Mongo automatically switches back and forth between those, which is really quite handy. I thought everyone had to be set up, saved as a long date, but that's only for doing comparisons inside the database. And so that's what that's for. So it gets the thing out of the database right here, keys.find, which is going to be used as this collection of API keys from the Mongo database. That's how that works. Let's see here. So that's how it creates an authentication key. And then I have for validating that each call comes in has that header. I wrote a little verifier. There was one that I found is this from this dev.forced, but he's not maintaining it anymore. So it only worked for Ktor 2. So when the Ktor 3, I was upgrading that to Ktor 3, it broke, and I was like, oh man. So I went in and looked at it. It's like it was a simple little error that it was that no longer the principal here is no longer going to be a string. It's going to be this any. So I just had to change it to any. It's really big deal. But I made it more easy to understand. Like validate it uses the validate function. There was a bunch of things that were odd about how he wrote things that made things extra confusing when I cleared all that stuff up. So this should be pretty easy to follow back and forth now. Let's see. So that there. Let's configure security, and it goes in here. So that's the API key, and that was that. I showed you how that worked. And when it comes in here, this is what I figured out. This challenge is only called if in the error condition. So I was like, what the heck? So where's that challenge happening? The challenge is actually being handled over here, where it does this API authentication provider, which is going to be this thing dot configure. Where is it? Registers it here. So that's the API key. Yeah. So that's registers it, and then it calls the validate function, which is right here. So let me see. Hold on a second. Yeah. So it calls the validate function here, which is set up right here. So this does the API key source, which is coming from this Mongo injection. So this right here, it's coming from this thing, which is this. So it's using that same database. And so that gets it there. API key source. So it calls this is valid key, which is like boop, is valid key right here. It calls that same thing. Keys.find. That actually does the database call right there. It goes off and gets it. And then here we set up the JWT, which is if you're authenticated, every call is going to have in the header is going to have a JWT token, which identifies the user ID and makes sure it's a valid JWT by making sure the signing is correct. And it hasn't been managed. That's what this thing automatically does even before it calls this. This is like extra stuff where I check the API key and make sure is in place. It doesn't actually check it here. I just do an extra check here to make it. So it does right there. It does that. Okay, so it does check it. So it's checking the database for the API key. If make sure it's valid every time. Make sure nobody's trying to do any funny business. Just because they have a JWT token, maybe their API key is invalid for some reason. So just another layer of checking. These things are super fast, but I mean, you could probably speed things up by not actually doing this check right here. but it's just another layer of security. It's easy enough to turn that off if it becomes an issue, but I don't think it is. I think I like to have that extra check there, just to be peace of mind. I don't know. You may not be as paranoid as I am. All right. Let's see. So that's creates the authentication routes. And then we have the register and login routes, which is right here. So register and login. These could probably be in their own like section, but this is fine. Um, Having these separated out like this it's okay, I think. So this is the register where you are registering with the request. So this does right here creates the hash. So if it's somebody, so the front end says, when it wants to register after I've already done the registration, but this basically does the same thing right here. Right here for doing the registration. Right here's the login. Um, and that says the login right there, and it gets the agenda. So it's getting all that stuff right here. That's what that all did right there. Okay. And here's the so when you register, it creates the users like hash and validation result, and here it is validate. So it validates the user. The names and stuff, passwords are correct and aren't too long or too big or have illegal characters and have right characters, all that kind of stuff. And then it checks to see if it exists already. If it does, it kicks it out, right? But if it doesn't, it creates a new refresh token, and then it hashes the password, and then creates a new user object, and then inserts that in the database, which ends up over here and looks like this. So it's got the email, the full name page, the hash password, the salt, the refresh token, which includes all the user ID and all that stuff. But no, this doesn't have that stuff. It's just a random string of numbers um, that's used to create a new access token every time. So that's what that's for. And let's see. Yeah, so that's what that's for. And then once the JWT is created, that's passed around. It's not stored anywhere. That's what's passed around and confirmed that it's been validated and created and by this by the service, and it's valid for this user. And when you do the login, it goes through and checks to see if that's verified with the hashing service. And then if it's debug, it'll just do something special. I should actually make that. Oh, it just expires the token. That's nothing big. Quicker than normal. So I should change that to environment variables, right? Environment dot config dot. Hold on here. See, it's always good to like do these walkthroughs on stuff for the people. You always find little things like this. So I added this environment, variables. So it injects the environment variables from this, from the environment. And I use the config of the create API key user there for doing for expiring the tokens earlier. So for testing purposes. So instead of waiting 2 days or a day or whatever, you want the refresh token or 2 hours or whatever. You can have just do 10 seconds for testing, and that's what that's for. Let's see, and then you have the authenticate, which is just takes the header, looks at the header, and or looks no, looks uses the JWT, just looks at the JWT, and checks to see if it's the correct thing. That Tasky will do that sometimes when it wants to authenticate who the person is. Let's see here. There's this. What's this one here? This is request a new access token. Yeah, so that'll go look up the user in the database and refresh and create a whole new authentication token based it's JWT, and create a new one. This is for the database admin, which is my side. This isn't in the Tasky application at all. This allows you to kill a token, which will force the person to log out next time they do. The Tasky will force them to will log the person out the next time they try and do a interaction, and the JWT is bad or killed. So that's another way of doing security for bad actors, or just limiting access to your thing. That's how kill. So I show in here how to handle kill tokens, which is accessing this database here, which has got this list of tokens of people that have logged out, or have been forced to log out. that's what that's about. And the way I do, the way you would do the kill token is you would, use Postman, or you could create a dashboard, I guess, and that to send off a post that will, given a JWT token, it will, it'll banish it. So that's what that does. Let's see. Um, Create API key. So this generates the API keys, allows you to allow these different clients to have a specific key for that particular client application, not the client user, but a client application. So it's just another layer of security that allows you to limit people's access to the backend unless you have all these credentials. Let's see what else I gotta say. I'm gonna do. So there's the routing here. Yeah, so this is for the application for the register, log in, authenticate, log out, create API key, request access token. So that one is right here. I go over that one. Yeah, so that, if you want to get the refresh and access token. So the access token refresh happens right here. And I'm going to need to actually change that one too. All right, I added a couple of those right here for using the same email from the configuration and variables, from the environment variables. I did that right here. I did that right here. It'll reflect into the source when you see it. Okay, so next time, the next segment, which is this is already gone for 20 minutes, I'll be talking about these other routes, and yeah, that's about it for right now. And maybe I'll pick up on some other areas, and give me a like and subscribe, and stay tuned for the part 2.